like to introduce the next speaker. That is Bjørn Isaksen, to talk about the Chapter 3 Rules and Regulation. I will ask Bjørn to share his screen.
Good morning. My name is Bjørn Isaksen and I am representing the Norwegian Public Roads Administration. I will briefly give you some comments on rules and regulations. That is relevant standards as Eurocode, especially relevant for European countries. ISO standards, that's International Standardization Organization. I will also mention some DNV standards, and at the end I will mention other relevant documents. As a supplementary, SFTB provisions may be found in a publication called Norwegian Bridge Design Manual, and it's N400 Bridge Design. It's unfortunately in Norwegian, but you will find it on the web free of cost. I will talk more detailed about Eurocode than other standards. And the simple reason for that is that this is the structural standard I am most familiar with. Nevertheless, some of my comments will also be relevant for other standard regimes. Eurocode, and this is first generation that which was published 2010. You have EN 1990 basis for design, which is the framework for all the Eurocode. And you have this important one, EN 1991, which gives you loads or actions, which is the term used in Eurocode. You also have the important 1992 concrete structures, and I mentioned 1993 steel structures as well. And in 1994, EN 1994, you have the possibility for using composite steel and concrete structures. You also have some other parts related to seismic design and geotechnical aspects and so on. Some comments in the beginning. The framework, and this is actually the basis for all of it, is given in 1990. But important environmental loads or actions are not given in 1991. For example, surface wave loads and current and tides. And the Eurocode has a great ambition. These structural design codes are intended to be harmonized with the execution, material and test standards, as well as technical specifications for construction and products. It's also worth mentioning that the second generation of Eurocodes is planned for release in 2027. The date of publication is in September, and the date of withdrawal of the relevant standards for today is March 2028. And then it comes to the ISO standards. The ISO 19900 series is relevant for design, construction, transportation, installations of offshore structures. And we are here talking about both gravity-based and floating structures, which is, of course, very relevant for submerged floating tube bridge. and it is applicable to the design of complete structures, including substructures, foundations, and mooring systems. Then you have ISO 19900 provides general and specific principles for the design of offshore structures. You have 19901-1, which gives you met ocean criteria, geotechnical and foundation design considerations, weight control, and marine operations. And it's also worth mentioning 19903, the second edition, which covering fixed and floating concrete offshore structures. Then to the DNV standards, and I will also comment the phrase standards. We are now talking about DNV documents. DNV, due to a organization process, it's now called DNV. It's earlier called DNV GL, Germanische Lloyd, and this is a ship classification company. Nevertheless, they have some very relevant documents, and what we can call offshore standards for structures reflecting more than 40 years of experience with marine structures, especially in the North Sea, but also elsewhere. I will mention specific these two documents, offshore structures C101 and of OS C502, which provides the general part of the offshore standards for structures. And these documents give specification of wind, wave, viv, and current actions, as well as their correlation, and that's load correlation, the design format, analysis approaches, and foundation design premises. Viv, that's vertex induced vibrations, is very important in the fluid dynamics and may be cause to severe design issues. So that's of special interest. Then what have we else? The other standards. Of course, it's worth mentioning the AASHTO standards, the American. British standards is very useful, often very useful, and of course it has to be mentioned here. And the American Petroleum Institute, they have published offshore structural standards, which is relevant. And in this context, especially interesting with this FIB model code for concrete structures, it should be mentioned, and this is due to verification of limit states associated with durability, robustness, and sustainability. And please remember this comment regarding verification to my next presentation in the afternoon. I will also mention something which is not written in the text. That's this NORSOK standards developed by the Norwegian petroleum industry. Also, we have a very interesting document, the DNV recommended practice, C205, which gives you information about the environmental conditions and environmental loads. And this document is due to a major update now in 2001-2022. It's also worth mentioning that reference may be done to immersed tunnel design and construction. Sometimes it's of special interest what's not written in the text, and here are some comments. A general principle in standardization, and a good example is Eurocode. That is, no mixing of standards is allowed. So Eurocode should not be used in combination with other national or international standards. This will, of course, be a big challenge in case of lack of information, as mentioned earlier today, especially in the load chapters in Eurocode. Also, it's worth remembering that the first generation Eurocode, that is the code which is relevant today, it was intended for structures as building and bridges, that is not including offshore structures. So there will be something missing when you try to use the code today for offshore structures. And a second important comment is that structures where structural dynamic response is relevant are in general not covered. The basis of design EN 1990, of course, has taken into account for these dynamic effects, but when it comes to the load chapters, it's not so simple. So dynamic structural dynamic response is often taken into account by simplified methods. And all these, I will call it limitations for use, may be a challenge regarding the submerged floating tube bridge. It's worth mentioning also an important EU directive regarding tunnels. The submerged floating bridge will be recognized as a tunnel. Nevertheless, a structural engineer, for a structural engineer, the SFTB is a bridge, of course. The directive, which came in 2004, it's named 2004/54/EC on minimum safety requirements for tunnels in the trans-European road network. And this directive is ensuring a minimum level of safety for road users in tunnels in the trans-European road network. It's also the case that a directive in this content is a legislative act that sets out a goal that all the EU countries must achieve. So implementation in the national legislation is mandatory, and that includes also the EFTA countries. That is, EFTA countries in this sense is Norway, Iceland, and yes, it's another country I don't remember. And then you have this, what do you call it, regulation, because that's what this is in the end. It's relevant for submerged floating tube bridges exceeding 500 meters in total length. So this gives, of course, a possibility for the SFTB and promote the SFTB with a length of 499 meters. Then you do not need to take all these requirements directly into account. And in a sense, this directive gives implicit requirements regarding the total length of the tube, number of tubes, number of traffic lanes, and of course, emergency and escape and safety provisions, which is the main concern for tunnel and tunnel directives. I think that's all. Thank you.